We are going to move on to section 5-7, rational exponents. We're going to start by simplifying these review problems. First, we're going to simplify 2 over the cube root of 4. In order to do that, we need to multiply by the cube root of 2 over the cube root of 2. In the numerator, I have 2 times the cube root of 2 over the cube root of 8. Cross out your cube root of 8, bring out a 2, then your 2's cancel, so you're left with the cube root of 2 as your final answer. The next one, when we move on, we have a binomial in our denominator, so we multiply by the conjugate. So I have 1 minus the cube root, or the square root of 3, over 1 minus the square root of 3. Distribute in the numerator to get 4 minus 4 square root of 3. And in the denominator, remember it's square the first term minus square the second term. So 1 squared minus square root of 3 quantity squared. When we simplify this, we have 4 minus 4 square root of 3 over 1 minus 3. So here, 4 minus 4 square root of 3 all over negative 2, which we then can simplify as well. Cross this off. This turns into a negative 2. This turns into a positive 2. So we have negative 2 plus 2 square root of 3. Next one, number 3, we're going to simplify this. We have 5, 20 splits up into 4 times 5, 180 splits up into 36 times 5. So we start simplifying to get 10 square root of 5 minus 12 square root of 5, which also simplifies into negative 2 square root of 5. In the next one, we do have to FOIL because it's a binomial. So when we FOIL, we get a squared plus 4a plus 4. And the last one, you cannot take the square root of a trinomial. So we need to factor our trinomial. When we do that, we get 3x minus 1, 3x minus 1. Because I have my binomials as the same things, I can rewrite this as the square root of 3x minus 1 quantity squared. Then I can take the square root of that. When I do that, I'm left with 3x minus 1. Moving on. For any non-zero real number b and any integers m and n with n greater than 1, we have a rule. The power, if my power is written as a fraction, the denominator is the root and the numerator represents the power that goes underneath our radical. So again, your denominator is your root, your numerator represents the power that goes underneath your radical. Here, same thing will happen, except where b is less than 0 and n is even. If I move on, when I simplify this for my examples, what it means is that I'm going to write this as the cube root of 8 squared. Well, if we think about it, the cube root of 64 can be simplified to equal 4. Or, next thing, cube root of 8 to the first power just gives me 2. We can do the opposite and write our rational exponents as radicals. In order to do that, I have the cube root of x. Here, I have the 7th root of y to the 4th power. And lastly, I have the 5th root of negative 5 to the 3rd, which then I can rewrite as the 5th root of negative 125. Moving on, writing each radical using rational exponents. So here, b to the 1/5 w to the 1/2. And down over here I have 3 to the 1/3 x squared z to the 2/3. Make sure your 6 divided by 3 reduces to x squared. We're going to evaluate each expression. Remember, whenever there's a negative exponent, it just means put it in the denominator. So this is actually written as 1 over the square root of 49, which is 1/7. The next one, I have the 5th root of 32 squared. Now if we take 32 and square it, it's going to give us a huge number. But I know that 32 is 2 to the 5th power. So I actually have the 5th root of 32 times 32. Each of these then is going to come out as a 2. So then I just have 2 times 2, which equals 4. Written in radical form, so in order to simplify this, I use my exponent rules. I multiply my exponents to get n to the 6/5 power, which is the 5th root of n to the 6th. I then can simplify this. 5th root of n to the 5th times n, so I get n times the 5th root of n. Moving on, simplify using rational exponents. In order to do this, remember we have to get our radical out of the denominator. A couple ways we can do this. So I can rewrite my numerator with a base of 2. My denominator also has a base of 2 underneath my radical. So now I have 2 to the 4/6 power over 2 to the 1/3 power. Well, this reduces to 2 to the 2/3 over 2 to the 1/3. They have a common base, so I can subtract my exponents. I'm left with 2 to the 1/3 power. Next one, I'm going to rewrite 8 with a smaller base. So the 6th root of 2 cubed. Then I can rewrite that as 2 to the 3/6, which is 2 to the 1/2 power. And lastly, if I multiply this, I get g to the 7/7, which is just g.